Hi guys, welcome back to my math YouTube channel. So I'm back with another example on evaluating the derivative of some basic functions. So guys, we already introduced the power rule and other basic rules. Now let us try to apply those to some examples. Guys, looking at this example, it seems like there's a quotient, right? There's a quotient. We're dividing a quadratic polynomial by a radical function. So just by looking at it, we cannot just directly use a power rule or any of the other rules. But we can simplify this expression, and once we simplify, then we may be able to use the power rule on this. Guys, so far we have only learned the power rule. So whatever expressions we get, we have to try and see how we can simplify them so that they qualify for a power rule, right? Later, guys, we're going to also learn some other rules called the product rules, the quotient rule, and so on and so forth. Then we may be able to use those other rules as well in order to evaluate the derivatives. In this case, we're still going to try to use the power rule. Guys, in order to use the power rule, we already know that it has to be like the functions have to be of the form x to the power n, where n can be like a rational, irrational, or an integer, right? So in this case, it does not directly or exactly look like that. All right. So what we can do in order to actually make it look like x to the power n form, of course, if we have some constants, we know how to deal with the constants. So what I'm going to do, or what we should do here, is like we can break it down into three separate pieces. So guys, we can rewrite this as 4x squared over radical x. We don't want to disobey any of the mathematical principles, but at the same time, we want to do things within the boundaries of the mathematical rules, and it is totally fine to break it down into three pieces because dividing this whole thing by radical x means that we are dividing each individual piece by that radical x. So it is this minus x over radical x, and then we can also write the last term as 3 over radical x. Still, we cannot see x to the power n form. So what we can do further is we can, guys, we can just get rid of the radicals or rewrite the radicals in terms of the exponents. We know radical as an exponent is to the power 1/2. So I can write this as x to the power 1/2. Same thing I'm going to do with this other ones, x to the power 1/2, and then 3 divided by x to the power 1/2, okay? So guys, keep in mind, I'm choosing these examples which are all different types so that you students, my students, can see these different types and different variety of examples, because my goal is like you got to see different types of these solved examples, and then when you do your homeworks or your classworks or you try to do these things on the test, you already are confident because you have seen so many variety of these problems. From here, guys, we know we can use the rules of exponents. And using the rules of exponents, what can we do here? We can just leave that 4 and this we just have to, we can just bring this term upstairs. If I bring it upstairs, it will be x to the power negative 1/2. Or you can just simply think of this as rewriting x and then just subtracting the exponents. That's the basic rules of exponents. When you have the same bases and you are dividing them, you just subtract the exponents. That takes care of this first one. This minus x, same thing here, guys. There's an invisible 1 as a power, so it's going to be 1 minus 1/2. And then the last one, there's nothing really you can do with this because there's no x here. So all you have to do is you just bring it upstairs. And when I bring it upstairs, I mean when I bring it upstairs to the numerator, it's going to be x to the power negative 1/2. That's what happens to the positive exponents when you bring them upstairs. The sign changes, it becomes negative. Right, so let us simplify and see what we have here. So guys, this is 4x to the power 2 minus 1/2. Obviously, we have to get this common denominator times 2 times 2. So it's 4 minus 1. And I expect that you guys can already do that, but I'm still doing it here. It's going to be 3/2, right? Because 2 times 2 is 4, 4 minus 1 is 3, and then 3/2. Minus, this is pretty easy. This is just 1/2. So we know 1 minus 1/2 is like just going to be 1/2, and then plus 3 times x to the power negative 1/2. So guys, this is the simplified version of this particular quotient form, right? And it was, I mean, we had to do some work on this, but it's not like so complicated to get it done. We just broke it into three pieces, converted everything in terms of to the power, like here we had to convert the radicals in terms of the exponents, and then we use the basic rules of exponents, simplified it, and now we can see this each individual term either as an x to the power n form or constant times that. So we know how to handle that. To find the derivative of this function, because we want to find the derivative, so it's going to be d over dx. I'm still writing some steps. X to the power 3/2, and then there's minus d over dx of x to the power 1/2. Okay, that's what I mean. There's a minus here, so we've got to keep the minus, and then there's a plus derivative of d over dx of what? 3 times x to the power negative 1 half, right? These three terms, so we got to find the derivative of each of these. Guys, this 4 we already know that we take the 4 out, so now I can skip a step and then only worry about the derivative of x to the power 3 halves. And we already know using the power rule, what we have to do is bring up the exponent and times x to the power exponent minus 1. So 3 halves minus 1. I will just write it and then simplify it in the next step. Then guys, minus derivative of the second piece, there's no constant multiplier, so I just bring that 1 half up front, then x to the power 1 half minus 1. We'll simplify that in the next step as well. Then the third one is just bring that 3 outside, and derivative of this thing, I have to bring negative 1 halves up front, then x to the power negative 1 halves minus 1. Okay. I think I need to get rid of just this much, or maybe I'll get rid of this whole thing. So let us rewrite this here, or we can already simplify a few things. Guys, 4 divided by 2 is 2. 2 times 3 is 6. So it's 6 times x to the power 3 halves minus 1. So there's an invisible 1 here, multiply by 2, multiply by 2. 3 minus 2 is 1 half, so it's 1 halves, right? 3 halves minus 1 is actually 1 halves, we already know that. And then minus 1 half, right? This 1 half. And then what do I have? I have x to the power 1 half minus 1 is negative 1 halves, right? And then the last term is going to be also minus, because I have 3 times negative 1. That's going to give me a negative 3 halves. And then what do I have? I have x to the power negative 1 half minus 1 is going to add up to negative 3 halves. You can also do the same thing like here, multiply by 2 and 2, and you will get the same thing. Guys, this is what we have for the derivative of this function, breaking it up, using the simplifying, and then using the power rule, and then also the constant thing. Okay, guys, this is example 2. I will see you next time with another example, which would be slightly different than this one, but it would still be using the power rule and just the basic rules. Okay, till then, take care.